All right, first you're going to work on the Chapter 8, Sections 1 through 5 warm-up. So this is a review of the first half of the chapter. So go ahead and pause this and take about 15 minutes to work on this. That gives you a little over 2 minutes per problem. And then we'll come back and see how you did. All right, so let's look at the first one. These were from 1 and 2 were from section 1 of this chapter. The variable x varies inversely with w, so you should have x equals k divided by w. Even though they didn't mention k, remember k is your constant of variation and should be there. Number 2, the variable b varies jointly with x and y and inversely with the cube of z. So b equals kxy divided by the cube of z, so z cubed. Okay. All right, number 3, simplify. So division, this is the time that we can't factor. So then I'm going to go ahead and rewrite the first one. Multiply by the reciprocal of the second one. And notice x was in the original denominator, multiplied by a number, and then x is also in the new denominator. So your restriction is x not equal 0. Now we try to get rid of what we can. Let me change colors here. Let's see here. So 3 goes into 12 4 times. These x cubes completely cancel. And we've got an x and an x squared, so we've got an x left here. And then 4 and 15, we can't do anything with those, so we multiply straight across what we have left over. So 4 times 4 is 16 x's on top. And then on bottom, we have just 15. And that can't be simplified anymore. Okay. All right. On number 4, we can factor all of these in some way. So this one would be x minus 3x plus 1. All over, take out a 2. We have x plus 1. It's already multiplied, so no flipping or anything here. 2 parenthesis x plus 5. And then x plus 5, x plus 3. So before you cancel, we say x cannot equal -1, -5, or -3. And what can we cancel here? We have an x plus 1 on top and bottom here. We have an x plus 5 on top and bottom here. And then we have these 2's on the outsides, on the diagonal. And then we have x minus 3 left on top and x plus 3 left on bottom. Remember, those are in parentheses, so you cannot cancel any of the x's, and you can't divide -3 divided by 3. Okay. All right, now let's look at addition and subtraction. So remember, with addition and subtraction, you have to have a common denominator. So for this first one, our LCD is going to be 15x squared. So you had to multiply this by 5. So that gave you 5x plus 5. And then multiplied by 3x here. And so that would give you 9x on top, all over 15x squared. So when you combine like terms, you get 14x plus 5 all over 15x squared. The x's are, this 14x plus 5 would be in parentheses because you see the addition sign, so you can't cancel anything. And our restriction would be x cannot equal 0. All right, for this one, our LCD is x plus 2, x plus 3. It's just those two binomials. So we multiply this one by x plus 3, because that's what it's missing. So when you distribute, you get 8x plus 24 minus, When this one we have to multiply by x plus 2. And then we're actually distributing a -5 to that. So that'd be negative, well, I'll write it. We would actually have let's see here. So -5x minus 10 when you distribute a -5 to that parenthesis, all over x plus 2, x plus 3. When we combine like terms, 8x minus 5x would be 3x. 24 minus 10 is going to be positive 14, all over the parentheses. So x cannot equal -2 or -3 is your restrictions. And we can't factor anything out of 3x plus 14. So that's our answer. Okay. All right. I won't be able to, I can't really anticipate which questions you would have on sections 1 through 5 worksheet. So when I come back, we can do any questions from that worksheet that you would like in addition to your assignment that would be today. Okay, no quiz today, so let's go ahead and get out your notes. Open your section 6 notes, and let's work those out. All right, so section 6 notes, your essential question that you need to write down, explain how to simplify complex fractions. So we're going to talk about what are called complex fractions today. Make sure you pause whenever you need to so that you can copy things down. All right, your one main idea today is just complex fractions, so make sure you write that in the left-hand column. And we have a couple of vocabulary terms. So the first one is complex fractions. And this is when you have a fraction within a fraction or fractions within fractions. Okay. Your LCD, we talked about what that was previously. That is the least common denominator. And we needed that when you're adding and subtracting fractions. And we'll need to figure out our least common denominator today to make these problems easier for us. Now, there are two different ways you could go about working these out. I'm just going to give you the one that's the least amount of work. But if you don't like this one, you can always come and see me before school, after school, or during homeroom, and I can show you how to do it the longer way. Okay. Okay, so how to simplify complex fractions. First, we're going to find the least common denominator of all the quote-unquote small fractions in the numerator and denominator of the whole big fraction. So that'll make sense when we do an example. Step 2, then we're going to multiply the top and the bottom of the whole big fraction by that LCD, because then it'll get rid of those fractions. That's what step 2 will do. It'll get rid of the individual fractions on top and bottom of the bigger fraction. Then we'll combine like terms in the numerator and denominator of the single fraction that's now left over. And then we'll see if we can simplify further. If we can factor things out, cross things out, etc. Okay. All right, so let's look at example 1. Okay, so when I see how we have we have what I call the smaller fractions are 1/2, 1/3, 1/4, 1/5. And then you have the whole big fraction, which is 1/2 plus 1/3 together, and over the 1/4 plus 1/5 together. So when I talk about the small fractions, I mean the 1/2, 1/3, 1/4, 1/5 in this problem. So for part A, we need to look at the denominators, which are 2, 3, 4, and 5 of the small fractions. So I'm looking at all the denominators of the smaller fractions, which are the numbers 2, 3, 4, and 5. And we have to figure out what the LCD would be for all 4 of those numbers. So you ask yourself, well, 2 and 3 have 6, but the others wouldn't. 5 and 4 have 20. 2 is divisible into 20, but 3 is not. 30 is divisible by 5, 3, and 2, but not 4. So our LCD is going to have to be 60. So this has to be the number that is divisible by all 4 numbers. And 60 is the lowest number that would be divisible by all 4 of those numbers. 2, 3, 4, and 5. Okay, so that's step 1, is finding that LCD. Step 2 now is to go to this fraction. Let me rewrite it. Step 2 says, now I'm going to take that LCD and multiply it times the top, both terms in the top, and multiply it on the bottom. And we can do that because 60 over 60, if I'm multiplying, that's just multiplying by 1. Okay, so then what that's going to give me is I do 1/2 times 60, which is 30. 1/3 times 60, which would just be, because these are over 1, so that would just be 60 divided by 3, which is 20. So the top now is 30 plus 20. Now we do the bottom. So that'd be 60 over 4, and 60 divided by 4 is 15. And then this one would be 60 over 5, which is 60 divided by 5, which is 12. So the reason why we do multiply the top and bottom by that LCD is that now we just have a single fraction bar. So all those little small fractions have been annihilated, basically. They're gone. Okay. Step 3 then says to combine like terms on top and bottom and see if simplify it a little bit. So 30 plus 20 is 50. Over 15 plus 12 is 27. Step 4 says to look at it one more time and see if you can simplify if there's something we can divide both 50 and 27 by, and there's not other than 1. So then that's my answer. Now you can check your answer by, this one has no variables in it, so you could type in your calculator 1/2 plus 1/3 divided by 1/4 plus 1/5. You would need to put parentheses around the top stuff. So parentheses 1/2 plus 1/3, and then parentheses 1/4 plus 1/5, and then you're dividing those. Okay. All right, let's try part B. All right, so on part B, we got to look at all the small fractions, their denominators, so that would be 3, 4, 5, and 6. And we need to figure out what that LCD would be. So then 3 and 4 are divisible by 12, and so is 6, but 5 is not, does not divide into 12. We could try 24, 6, 4, and 3 all divide into 24, but 5 doesn't. So as you go through this process, 60 actually happens to be our LCD this time again. So 3 divides into 60, 4 divides into 65, and 6 both divide into 60. Okay, so then I'm going to go back. 1/3 plus 1/4 all over my 1/5 minus 1/6. Okay, so now I'm going to multiply this top by 60, and remember that's like 60 over 1 when you make 60 a fraction. And so when I do that, this would end up being 60 divided by 3, which is 20, plus this would be 60 divided by 4, which 4 goes into that 15 times, all over. This would be, when you distribute the 60 to the 1/5, that's going to be 12 minus 1/6 times 60, which is 60 divided by 6 is 10. So that's step 2, is to multiply top and bottom by your LCD, so you end up with a single fraction. Step 3 then says, okay, let's combine like terms. So 20 plus 15 is 35, all over 12 minus 10, which is 2. And then step 4 says to look and see if you can simplify any more, and we can't. So this is what you do, and the same steps we're going to do for all of these problems. These didn't have any variables in it, so they were a little easier. And like I said, when they don't have variables in them, you can plug them into your calculator and check your answer. Okay. Now, since these are fractions, your answer should be in fractions. So I don't want you to take 35 divided by 2 and then give me the decimal for that. Just leave it as 35 halves. Okay? All right, now let's look at a problem that has some variables in it. Okay? Doesn't necessarily mean they're harder. This one just means we can't plug this into our calculator to check our answer. So we have a plus b over b is the small fraction on top, all divided by a minus b over ab, which is the small fraction on the bottom. So step 1 says we need to find the LCD for this b on the bottom of the top fraction and ab for the top or the bottom of the bottom fraction. So our LCD here would be a and b, because again, you have to look at this denominator and this denominator of the smaller fractions. And so between b and ab, then we would have ab. Okay? All right, so then step 2 says I need to multiply this top by ab and multiply the bottom by ab, so we can get rid of these fractions. Now, when we do this, there's only one fraction on top, so this b cancels with this b, because remember, this would be over 1. So you're left with a parentheses a plus b, and we're just going to leave it in its factored form like that. All over, and then remember, this would also be over 1. The a cancels and the b cancels, so all that's left on the bottom is a minus b. And this is the fact, and we'll just, like I said, we'll leave it in the factored form because we want to see if we can cancel anything. And so we're left with this, and we can't combine like terms. Even if I distribute the a, I'd get a squared plus ab, and those are not like terms. I can't cancel the two parentheses because they are slightly different. So then this is your final answer. And this is simplified because now you only have one fraction. Simplify means we can't have fractions within fractions. You can just have a single fraction bar like we have there that's boxed. Or like we had here, we had 35 halves. Okay. Okay, so then let's go ahead and try part B. All right, so for part B, we have m minus n over m squared. So that's one of the small fractions that's on top, or that is the small fraction on top. And then on bottom is the small fraction m minus 3 over mn cubed. Okay, so for the LCD, we have to look at the two denominators of the small fractions. We have m squared and mn cubed. What would this LCD be? Well, for m, you take the highest exponent, so that's m squared, and then we have n cubed. That's the only n thing we have. Okay? All right. Actually, all right. So we have m squared, n cubed that we're going to multiply on top and bottom. So m squared, n cubed, so this is step 2. We're going to clear these smaller fractions and just have the single big fraction. Okay, so then the m squareds completely cancel. And so I'm left with the n cubed and then the parenthesis m minus n, because you would have to distribute that, but I don't want you to distribute it because it's already in its factored form and we like it in the factored form best. Okay, on the bottom, the n cubed is completely gone. One of the m's is gone and there's an m left here. So on bottom, you have an m parenthesis m minus 3 left. Now we have a single fraction. Then we look to see if we can cancel anything, and we cannot. So then this is your final answer. So that's why we reviewed all of the multiplying of monomials and binomials and things like that, so that on this diagonal here, we can cancel some things out and make our fractions simpler. All right. Example 3. Last type of example. And we're going to review more tomorrow So you won't have a quiz tomorrow over this because we're going to take 2 days reviewing this concept of complex fractions. So you won't take the quiz over this until Thursday. Okay? Because we'll practice more in class tomorrow when I get back. All right, part A. We have 1 over w minus 1 minus 3 over w. Those are the small fractions on the top of the big fraction. Then we have 2 over w plus 5 over w minus 1, which are the small fractions on the bottom of the big fraction. So step 1, we got to figure our LCD. So our LCDs that we're looking at is we have the w minus 1 and w, and w minus 1. So what do you think that our LCD should be? Yeah, it's going to be w. We have 2 fractions that have just a single w, and then we have 2 fractions that have this w minus 1. So our LCD is going to look like that. Okay, so then we'll take this fraction, multiply it by w minus 1, and we'll take this set of fractions on the bottom and multiply it by w, parentheses w minus 1. Okay, so when you multiply this fraction, the first fraction in the top, by this LCD, you'll notice that the w minus 1's cancel, and then you're just left with w on top. Okay, so I'll just write that w there. Minus, then when I multiply 3 over w by this, the w's on the outside cancel, and then you're left with the 3 parentheses w minus 1. So we're left with 3 parentheses w minus 1. All over. Now if you look on the bottom, you have 2 over w times the LCD, so the w's cancel. So you're left with the 2 parentheses w minus 1. So 2 parentheses w minus 1 is that first term that's left. Plus, you've got 5 over w minus 1 and the LCD. The w minus 1 cancels. So you're left with 5 times w, which is 5w. Okay, now we need to do step 3 where I will distribute because you'll be able to combine like terms. So I distribute that -3 and get -3w plus 3. And then distribute the 2, so you get 2w minus 2 plus 5w. Then we'll combine like terms. W minus 3w is -2w plus 3 on top, all over 7w minus 2 on bottom. Now this is in parentheses because you see a plus sign, and this is in parentheses because you see a minus sign, so you can't cancel the w's. So then, whoops, this is your final answer. As far as you can go, we can't cancel anything, so we're done. Okay. All right, last one, part B. All right, so part B, we have 3 over x plus 2 minus 2 over x plus 3. Those are our 2 small fractions. And the top, all over 1 over x plus 3 plus 4 over x plus 2. So first we need to figure out our LCD. So I look at what I have. I've got x plus 2, x plus 3, x plus 3, x plus 2. So then what should our LCD be for all 4 of those? Should be x plus 2 and x plus 3 as your 2 parentheses multiplied together. Okay, step 2. We're going to multiply top by that and multiply the bottom of the bigger fraction by that. And if it helps to make that over 1 so you can see diagonally what you can cancel, go ahead and do that. So 3 over x plus 2, the x plus 2 cancels with that x plus 2, and you'll be left with 3 parentheses x plus 3. So we have 3 parentheses x plus 3 left for that first term on the top. Minus this one, we can get rid of the x plus 3 with the x plus 3. So we're left with 2 parentheses x plus 2. All right, now we do the bottom of the big fraction. So I have 1 over x plus 3. The x plus 3's cancel. Oops, that should have been. One of these should have been an x plus 2. So the x plus 3's cancel, so you'll be left with 1 times x plus 2. Change that back in a second. So we have 1 parenthesis x plus 2, but we won't need to put the parenthesis or the 1, but I'll put x plus 2. Okay, so then on the second 4 over x plus 2, the x plus 2's cancel, and you're left with 4 and x plus 3. So plus 4 parenthesis x plus 3 is what's left over. Okay, so then let's simplify, distribute, and combine like terms. So this will be 3x plus 9 minus 2x minus 4, because you're distributing at -2. Then you have x plus 2 plus 4x plus 12. Combine like terms, we get 3x minus 2x is 1x, 9 minus 4 is 5, and then x plus 4x is 5x, 2 plus 12 is 14. And that's your answer, because you can't cancel anything, because x plus 5, you see an addition sign, that should be in parentheses. 5x plus 14, you see another addition sign, that should have parentheses around it as well, so you can't cancel the x's or the 5's. Okay. All right, so now you're going to practice by doing the exit slip. We'll work this, the LCD together. So you put A over 1, the fraction. So what should your LCD be for this one? You've got a 1b, A, and B in the 4 denominators. You should have A times B as your LCD for these. Okay, so now go. So now you're going to multiply this by AB and this by AB and get it going and simplify it. Once you're done, substitute, and then the sub will check you off that you did your exit slip, so I can give you your point for that. And then your assignment is section 6, worksheet number 1. There are 2 of them because tomorrow will be more practice with this, but you're doing worksheet section 6, worksheet number 1. So make sure you're doing the right one. There's only 4 to practice. I figure if you can do those 4, you should be good. Okay? If not, come see me before school, after school, or during homeroom this week if you need some additional help with